Triaxial setup is a machine that has two panels for two lines of pressure, one for side pressure, one for back pressure. It means pressure outside the sample and pressure inside the sample called back pressure. The two lines of pressure are regulated by this air-water bladder that makes the pressure inside the chamber, and the pressure is replaced then inside the triaxial cell. But for this kind of setup, you need a water tank with water installed and their air water. You have the water there. Here there is the vacuum pump that will takes all the air from the water tank. So in this way, the water is prepared to the triaxial test as distilled and the air water. So this is the initial operation. You have to release open, and after a few seconds you will see the bubble from the water tank, and when the bubble finished, it means that all the air inside the water tank is kept. When it's finished, you will shut off and remember to close to open the valve. You will see the noise of the air, the vacuum that is released till it's finished. This is the first part of the preparation of the setup for the triaxial test, because in this way you are preparing the water for the saturation of the circuit and for the preparation and for the test, general test. The water tank has a valve to the bottom, and that valve with a hole comes here. So this is the valve that comes from the water tank. In this case it's open, and the valve distribution takes the water in two panels from this valve. So this valve and this hole come out with this valve. When these valves are open, means that the water is inside, and this is the water output, the valve for the water that goes in the back and comes here for the cell pressure line, here for the back pressure line. In this case, the air-water bladder are full of water, but if they were empty, the things to do was close here and here, one per time. Open this, the water is able to arrive here. This is open, and the water come in the chamber. This valve is open so that the water, the air inside the chamber goes out. And when the water come out, you can close the valve, and the chamber is empty, is filled of water. Then you can reopen this and perform the same things with the other one. After this is the water circuit, the principal valve for the water circuit. And as I said before, this is the line for the cell pressure that comes there in this way and arrive to the triaxial cell. In the same way, this is the line for the back pressure, but the difference is that the line of cell pressure has nothing between the air bladder and the triaxial cell. Regarding the back pressure, we have here in the middle, we have the volume change device. It helps you to understand how many water goes inside the device, goes out of the sample during the consolidation phase. So it is placed in volume change and bypass according to the phase of the triaxial test. During the saturation, doesn't matter how many water pass here. So it is takes to bypass. During the consolidation, you want to know how many water goes inside goes out of the sample. For this reason, it takes as volume change. And according to the position of this bar, you can select flow down or flow up. In this case, flow up because it's all on the top, on the bottom. Okay. This is the water circuit, but because of the air-water bladder needs the air to create pressure, we have a compressor here with a hole that is connected directly here. This is a filter, and the air comes here into the filter and goes out and comes here. In this case, it's open, and the valve distribution it gives the possibility to have the air directly from there and there, directly inside the air-water bladder. And this is the valve that gives the pressure inside the balloon, and it's connected with this valve directly with this hole in the balloon, so that it's possible to have a closed circuit of the air, for both the bladder and this is the principal setup. Here there are the pressure transducer. This is for the back pressure. It means this panel. This is for cell pressure. It means the other panel. And this is for the pod pressure. The difference is that the cell pressure and back pressure have their line of pressure that you can see also in the panel. This is only a feedback of the sample. It means that this kind of transducer is only a reading of pressure inside the sample. You don't have to manage this pressure transducer. It's just a reading. But because you have to saturate all the circuit, all the parts of the triaxial sample, it means also the base of triaxial cell placed there should be saturated of water. So when you saturate the circuit, you have to be sure that the water goes out of this hole. And the same things for this. This is the top cap, is connected to the blue hole, and using this hole and this line, opening this, the water goes inside the blue cable, and you will see the water out of this hole. It means that also these tubes, this hole is saturated and the water is not inside it. You have to be sure that all the system is saturated, and this is important because even if it's not saturated, you have air inside the system, and the principal things that you have to do is dilate the air of the system. So to do this, and also to understand if the pressure transducer reading is correct, you can have a double check. You can increase the pressure using the valve and see the pressure on the panel, and you will see also the value of the pressure transducer on the machine. For example, you will see that the pressure increasing in the panel, and according to the right pressure transducer, you will see that also the pressure on the machine increase. It means that the pressure transducer and the panel are in line, are okay, are correct. If you see something different, you have to adjust the calibration of the pressure transducer. But in this case, the calibration is done. For this reason, you will see the same value on the panel and the machine according to the right pressure transducer. It's important because here to see that the panel is in kPa and the machine is in megapascal. So you need to be careful about the value that you read, because the unit is not the same. But the value is for sure it's the same. The machine is equipped with the 2 icons because you have to perform three phases to finish the test. But the first 2 phases, saturation and consolidation, must be done using this data logger function. And only the last phase of test, the shear phase, must be done with the triaxial icon. You have to select the speed at which you want to reach the failure of the sample, and you have to select also a data logger function for all the transducer that are recording volume during the shear phase. In this case are not indicated, but you can decide to select file for each channel connected, and the machine will give you a file, a TXT file, in which all the channels are recorded during the shear phase. If you want to check also the channel, you can see here the profile, and you can see, for example, that the load cell is placed in channel 1. The 3 pressure line are from 5 to 7, and you have to know which line is the right pressure. For example, in this case we have channel 6. You can see here only pressure, but channel 6 is the cell pressure. So you have to record which kind of line of pressure is the related transducer. Because here you can see only load, displacement and pressure. But you have to know which line of pressure and which displacement is related to this channel. The shear machine is equipped with a load ring and DL gauge, and is able to apply a vertical load for the consolidation phase, and then a shear movement in horizontal direction that gives the maximum value for the strength of the soil before the failure. And as I said, it's equipped with a load ring, so that during the shear movement, during the horizontal movement, the load ring will increase its value, and in the same time the DL gauge will record the movement of the carriage, and the DL gauge in vertical direction is fixed because this system is fixed. It's always this one that is moving. But for the first phase of the test, it means the consolidation. The setup is done like this. You place the shear box with the sample inside for sure, with the water, fill the water inside the carriage, and place the screw on the top of cap of the shear box. In this case we have not a real sample, but consider for example that the top cap is up and it's placed on the screw, above the screw. This is placed all in contact, so the top cap, the screw and the dial gauge are in the same line, all in contact. And I suggest you start the test with all the dial gauge compressed, because during the consolidation the sample will be compressed and it means that the dial gauge will extend it. And how to apply the vertical load. It's use a lever with the support The support helps you to select the right weight without applying load. When you are setting the load and you are placing the weight, the support takes all fixed. It's not moving, so that the sample is not having a preload. When you place the weight, remember that because of a lever, you have a ratio of 1 to 10. It means that if you place 1 kilogram here, you have 10 kilogram on the sample. And with the conversion from kilogram to kilonewton and with the area of the sample, you know how many kilopascal you are on the sample. After placing the weight here and starting the manual acquisition in this case, because there are dial gauge, you will remove the support, and as you can see also with that weight, if I move the lever, also the plate here is moving. It means that it's applying a load. Now it's fake, but the logic is the same. You will apply a load that will move the lever and will apply the load to the sample. And for sure the sample will compress it and the dial gauge will extend. You have to adjust it so that you can start from zero. It's better for the acquisition. When the consolidation is finished, it means that you don't recognize any movement from the dial gauge. It means that the sample is compressed totally at this kind of pressure. You can start with the shear phase. And to start with the shear phase, you have to go on the machine with this icon, shear, and select here the acquisition. That is a standard acquisition, so I suggest you leave it like this. And you have to choose the speed according to the sample and the shear threshold. It means that the machine is moving for this threshold. For example, 10 millimeters could be enough, 10, 12 millimeters could be enough. If you use 5 millimeters, it means that the machine will move only for 5 millimeters, and it's not enough generally. But it depends on the sample. Okay, so the very important things is that during the consolidation, after the preparation of the sample, you will have this nut fixed, because the two parts of the shear box needs to be fixed, needs to be put together. But when the shear phase starts, it's very important to remove the nuts, because the shear box is able to moving, and the sample could be sheared. If you forget to remove this, happen something like this, the nuts will be yes, will be damaged, and the test failed for sure. Just to show you. Right way to place, you have to release this, this is the shear box. So when you prepare the sample, the screw are placed, because as you can see in this moment the two parts were not in the same line, but during the sample preparation they must be fitted, because the shear box must be in the right position. So you will start from if the sample is inside the shear box, you will start with the top cap more or less in this position, and after this you can place it in the shear machine, and you have to fit also this. I'm moving just to show you, and to move this, to fix this so that it's all fixed and it's not moving, you can move this nut in the direction of in the other according to the shape of the shear box, so that this base is taken to the shear box. For example, in this way, and then remember to close the in this way. The shear box is fixed in the carriage, and closing this nut, you close and fix all the axes, horizontal axis, so that any movement of the carriage could be recorded from the dial gauge and the load ring, so you understand what's happening in the shear box. Because it's generally it's a drainage test, you have to fill the carriage with water, and after finish of test, opening this valve, the water can go out. And when you finish the test, for sure the carriage is moving in this direction, and the things that you have to do is to take the carriage in the zero position. This is a warning, say you, if you have a load control, a load cell or load ring, pay attention, because you are moving the carriage in manual way. So you can set 0 here, but now it's in the 0 position, but you can set 0